Hey everyone, so we're going to continue our discussion with kinematics and motion, and we're going to talk about something called acceleration. Now, acceleration is the next part. We talked about how we could talk about how fast you change your position, and that would give us our speed and velocity. Well, speed and velocities aren't constant; they also change as well. So we can compare how fast or how quickly these speed and velocities change, and that's what acceleration is. So acceleration is represented by an A and is the rate at which an object's speed or velocity changes. Now, it's actually specifically the rate at which the object's velocity changes. So, because of that, acceleration is a vector. Acceleration does have a direction, and direction matters. Now, one thing that I want to point out is that acceleration and velocity are not the same thing. This is very important to note. You might think, oh, that, of course that makes sense. One's velocity, the other one, like how fast you're traveling. The other one is how quickly you're changing your velocity. However, one of the common mistakes that people have is that they sometimes misattribute uh, them as the same thing. For example, you might have a scenario where an object is accelerating very quickly, but its velocity is zero. And likewise, you can have a scenario where an object can be moving at a very high speed but have zero acceleration. So it's important to note that these values don't both have to hit maximum values. And in fact, they don't even have to be in the same direction. You can be traveling to the right but accelerating to the left. That is something that also happens. So please be aware that acceleration and velocity are not the same thing. They are related to each other, but they are not the same. Now the units for acceleration are meters per second squared. Now you may notice a pattern. Distance and displacement were meters, speed and velocity was meters per second, and acceleration was meters per second squared. In this class, that's actually the end of the acceleration line. We stop at acceleration. That is the most complex thing that we'll talk about with the motion of an object. However, in later classes, there are higher levels. And you could bet that if they follow this pattern of meters per second cubed, meters per second to the fourth, and so on and so on. Now, acceleration, like I said, is a vector, which means it does have a direction. You can attribute left or right direction, but it also can be positive and negative. So what does it mean when we have a positive or negative acceleration or an acceleration in a certain direction? Well, it means that the object speed is increasing in that direction or that the object wants to go positive. Now, what's important to note is that it doesn't mean that that the speed is increasing. It just means that the speed is going in that direction, or the velocity is going in the positive direction. So if your velocity is already positive, then having a positive acceleration means that you're going to speed up because you're going to become more positive. You're going to increase in the positive direction. But if your velocity is in the negative direction, then that means your object is slowing down because it's trying to go into the positive direction. So, uh, one way to think about this is that if your acceleration and your velocity are the same sign, both positive, then you're going to be speeding up. If your acceleration and velocity are opposites, so one's positive, one's negative, then the object will be slowing down, and it'll slow down until it reverses or comes to a stop, whichever one comes first. Um, then for the negative acceleration, again, same thing. It's increasing in the negative direction or decreasing in the positive direction. Doesn't really matter how you phrase it. Same thing applies though if we have a negative acceleration and a positive velocity or they're opposites, the object's slowing down, but if they're the same sign, it's going to end up speeding up. And that's exactly what I say over here. Now, there are a few equations that we have for acceleration. The most basic equation is this. V equals V naught plus AT. V is the final velocity, V naught is our initial velocity, A is the acceleration, and T is the time. Once again, make sure that your units are in the proper notation or at least consistent. A lot of times your acceleration is going to be meters per second squared, so you're going to want to make sure that your velocity is also in meters per second. This is actually why I usually say that unless explicitly said to use a certain unit, you want to try to make sure that your distance is always in meters and your velocity is always in meters per second. Um, so this is our most basic equation, and I actually call this the acceleration equation. There is another form that you might see of it on the Regents reference table, but I wouldn't worry about it. Just use this one. This one's the nicer equation. In addition to this, There are two other equations. There are slightly more complex. They're only really more complex because they're not as nice as b equals v naught plus at. It I can show how these get derived later on in class if you're interested. They are pretty nice. But I do give them extra names. So the x equals x naught plus v naught t plus 1 half at squared, I call it the annoying x's equation. The regent's equation does have an equation that's very similar to this. That one I call the magic